In this section, we're going to look at how is water used. So a couple terms here. Withdrawal is the total amount removed from a lake, river, or aquifer for any purposes. Consumption is the amount lost in transmission, evaporation, absorption, chemical change. Consumption is very much impacted by human use. In the United States, we tend to treat water as if it's an inexhaustible supply. This is certainly not true. Think about what's going on with the drought in California. All of the farmland that was put in place that is now running into serious problems because the precipitation hasn't happened, and therefore they can't irrigate, the breadbasket is drying up. What can we say? Per capita water use, U.S. versus the world. On average, the annual water withdrawal worldwide is 170,544 gallons per person. The U.S. has enough water to supply 2.4 million gallons per person annually, which is well over the average worldwide. We use 1,300 gallons per day. Compare that to Haiti, which uses 8 gallons per day. The U.S. is a huge consumer of water. This graph shows that the U.S. water use per person per day. Here, notice it's in liters, so the numbers aren't going to match up to what's over here, but if you did the conversion, it should. The U.S. is between 525 and 600. Pick another one. The United Kingdom, England, is right around 150. China is closer to 75. Consider Las Vegas. What is Las Vegas? It is an artificial oasis. In order for Las Vegas to exist, you have to have water piped in. It's in the middle of a desert. Right. So how do we get the water to Las Vegas? Well, we put up the Hoover Dam on the Colorado River. And by that dam, we now have a water source for Vegas and other areas. There is a film called Cadillac Desert, Mulholland's Dream. It's available on YouTube, which goes into how the water supply for Los Angeles was developed. But in a great many ways, both Las Vegas and Los Angeles are anthropogenic mirages at the geologic scale. They would not exist if we did not pipe in water. Here is a picture of Mono Lake back in the day. Where is Mono Lake now? Oh, there was a link. Hold on. If I look at the same lake today, hopefully this pulls up. There's a picture. I don't know where the now picture is. Oh well. So, on to the breadbasket, San Joaquin Valley, California. Remember, this area has been hit by a drought. So currently, it is trying to get water any way that it possibly can. So the question is, how do we allocate clean water distribution? Right. In order to get water to the San Joaquin Valley, we're doing things like building aqueducts and canals. Right? What happens to the area that used to have the water going through it and no longer does? Groundwater is the primary drinking source for about 50% of the U.S. population. Anywhere there's a well to get water, you're taking it out of the groundwater. If you have overdraft, you have more being extracted than refills. This graph here shows overdraft. Yellow means no. Orange means moderate. Orange is critical. They are using more than is coming back in anywhere that is orange. The little inset here shows you how the water level is changing from pre-development in 1940 to post-development in 1993. Anything that is yellow shows a rise. Anything that is orange has a change between 15 and 3 meters. So might have gone up a little, might have gone down a little, but nothing much. Anything that is red is a significant decline of over 15 meters, which is 50 feet. On average, about 5% of groundwater is depleted. And as that graph showed, in some areas, it's more than 15 meters depleted or declined. Why is it being depleted? Well, we're using it for the purpose of agriculture. Put in a well to irrigate the fields, but it doesn't percolate back down into the groundwater. Instead, it evaporates and goes elsewhere. This is another graph that shows water level change in feet from, I think that's 1950 to 1995, best of my ability to read it. Orange is more than 40, and the green is area of little to no, I can't read it. It's not much change. Purple is more than 40 feet rise, though. Worldwide, crop irrigation is 2/3 of water withdrawal and 85% of consumption. Consumption losses are primarily via evaporation or seepage from unlined irrigation canals. In India, 90% of water is used for agriculture. In the U.S., we're closer to average, with 50% of the water withdrawn and 80% of consumption is agricultural. All right, Qatar is a desert, but look at these lovely green irrigated fields. Here's a picture of the Midwest showing the irrigated fields again. But remember, it's not always been happy and joyful in the U.S. In the 1930s, we had the Dust Bowl, a big drought. Right? Droughts are worse in semi-arid and arid regions. Not a big surprise. If you disturb an ecosystem, it's not going to rebound readily. Pictures from the Dust Bowl back in the day. These are clouds of dust being blown across the plains. Look at how the Aral Sea has changed from 1977 to today. What you're seeing is loss of water and increased land mass because the water's been depleted. This little bit used to be an island and is now connected. So managing water, we have an increase in demand because we have increased population, increased industry, which requires increased agriculture. We have supply problems in arid and semi-arid regions. Think California and megacities of humid regions like New York. What can we do to manage the Colorado River? The Colorado River is being tapped for Las Vegas, for Los Angeles, but that water originally went somewhere else, so we've got other impacts as well. We have to conserve. We need to regulate irrigation. We need to put systems in that reduce evaporation. We need to improve efficiency via technology, like using low-flow fixtures. We have to increase, reduce, and recycling. So we need to think about what we're doing with stormwater catchment. Can we use stormwater for flushing toilets and washing laundry? Can we use gray water for wetlands, for irrigating landscapes and crops?